we are going to start using textures in our materials. Let's start with the definition. So, what is a texture? In computer graphics, a texture is basically an image that we use to enrich our materials. Some people, and even some 3D software, like to call textures as maps. So, don't get confused when you see the words diffuse map instead of diffuse texture, for example. They basically mean the same thing, okay? A simple cube object, for example, can look like a brick if we put a brick texture on its material. Or it can look like a stone if we apply a stone texture, and so on. In general, there are two types of textures: procedural texture and file image texture, or just image texture for short. So, what is the difference between the two? Well, procedural textures are images that are produced dynamically through programming. So, usually, we can easily control how they look simply by tweaking their parameters. Most of the procedural textures are generated in 3D space. This means that it can be easily applied to 3D objects without the need of UV mapping. We will discuss UV mapping in more detail later. In short, UV mapping is a method to place 2D images on 3D object surfaces. The downside of procedural textures is that they do not look realistic, or at least it is harder to make them look realistic if we compare them against image textures that were taken from photographs of the real material. The last downside of procedural textures is that it is almost impossible to transfer them to other software, because they are basically a program generated specifically for a certain 3D application. We can, however, bake them into image textures if we need to transfer them to other applications, but that will be for another lesson or another course. The second type of texture is image textures. Unlike procedural texture, image textures are stored as image file formats such as JPEG, PNG, EXR, HDR, etc. Most of them are captured from real-world materials through photographs or other means. So, in most cases, they look more realistic than procedural textures. Because they are 2D images that we need to place onto the objects, we need a way to map them correctly. This mapping method is what we call UV mapping. Again, we cannot use image textures if the 3D models do not have proper UV maps. The nice thing about image textures is that they are accepted globally or can be used across different 3D software. Let's discuss the procedural texture first, and then later discuss image textures, and finally UV mapping. To create a procedural texture in a shader editor, you can press Shift-A, and then open the texture submenu. As you can see, Blender provides more than a dozen texture nodes. Almost all of these are procedural textures, except, of course, the image texture. Besides the image texture, this environment texture and IES texture are also not procedural textures, as they need external files to work. We will discuss them later. For now, let's create a procedural texture node called the brick texture. As the name suggests, this texture node generates brick texture. But as you may notice, having a node inside the shader editor does not automatically affect the material. We need to connect this node to our main material, which is using the principled BSDF shader. In Blender, the way nodes work is like this. The left side is the input, and the right side is the output. So the data flows from left to right. Okay? In the brick node, these two dots are the outputs, and these dots on the left are the inputs. To use this brick node, we need to connect the output that generates the colors to the input dot in our main material node. If we drag this color dot and connect it to the base color dot, now the original base color we had before is overridden by the color output from the brick texture. If we check the material panel, notice how we cannot access the color box like we used to. Instead, it is now replaced by this caret button that we can use to expand or hide the brick texture parameters. So again, the parameters you see here now are basically the same parameters you see in a brick node. Let's say we want to change the first color of the brick to red. Change the second color variation to a brownish color. As for the mortar, we can try a light gray color. Besides colors, there are plenty of parameters that we can tweak. We can control the scale of the texture, or control the size or the width of the mortar, and so on. Feel free to experiment with the rest of the parameters if you want. Essentially, as I mentioned before, procedural textures allow us to change the way they look dynamically. Alright, now notice as I disconnect the dots. The original control for the base color is back. This basic working concept applies to the other dots or parameters. For example, if we connect the color dot to the metallic dot instead, now the original metallic slider is gone, replaced by the brick texture. Please note that the metallic slider is one channel value, while a color is a three-channel value. Remember our lesson on the color model. A color contains red, green, and blue values. The reason why we can plug color data into metalness data is because Blender automatically converts the color into a single channel, or in other words, a grayscale version of it. In this condition, in areas where there are bright colors or near white, the surface becomes closer to metal, while in areas where the color is dark or near black, the surface becomes more dielectric. Okay? If we connect this to the roughness dot, now the brick texture controls the roughness of the material. White becomes rough, and black becomes glossy or reflective. Another example, if we connect this to the alpha parameter, all black colors become transparent, while white colors become opaque. From this example, I believe you already started to see the big picture of how a complex material can be composed using textures. Without texture, you can only define a single value for the entire surface of the object. But if we use texture, we can vary the value on different areas of the surface, and we can do this on each of the material parameters. This gives us more detailed controls over how the object should look. In theory, you can convert one output dot to multiple input dots at the same time. But in most cases, you do not want to do this. To achieve the best result, you should provide each parameter with specific textures designed to be used with that parameter. We will cover this in more depth later when we discuss PBR textures. One last tip that I want to mention is that when you need to disconnect a lot of connectors like this, click dragging each of them one by one can be time consuming. In such a case, you can just hold the control key and then, using the right mouse button, perform a drag across these connectors to cut them all at once.